quickly do an example of how to get a program started. So I figured I'd work it through. Open up your lab view and under FPGA target here, hit go. I don't have the FPGA with me, so it'll work fine for you connected. It'll work better for you connected, actually. So if you drop down here and say it's a single board RIO embedded system, we go next. And then here's where it should automatically detect whatever you have connected. So if you have the RIO on at this point and connect it up, it should work fine. I'm going to create a new system since I don't have it connected. And then I happen to know that we have a 9636. But it'll do all this automatically for you because yours is already connected. And then it says it'll create a project for you. You'll notice that there's a project. Here's your RIO. If you go under chassis, you'll see the FPGA. These are all the stuff that you have connected to it, but there's no program. So the first program would be to go under the real-time machine and say, let's do a new VI. You see that'll put a new VI in this level of the project. And you can see down here that this is running on the RIO. So this is the real-time machine. So if I want to multiply two numbers, I can say, it's a little bit hard because my screen is so small, but you can put in multiplication of two numbers. I'm not going to be able to do it on a smaller screen for recording, so let's actually just doesn't really matter. Here we go. Let's multiply two numbers. So I'll create a control here and here, and create an indicator. And you'll notice that when you hit run, I can't hit run because it's not connected, but when you hit run, it'll actually ask you to save it. I would recommend saving everything in a folder structure specific for this project. So you have one folder that has all your projects, so you can obviously do that. And it can't deploy it unless it saves it. It also can't deploy it if you don't have something connected. But if you hit run, you could change these numbers. You could hit continuous run if you keep changing the numbers, and you could see this value change. All right. You can also do this on the FPGA. So you can say, record a new VI here. Now you can see I'm on the FPGA target, and we could actually have exactly that same code. So if I go back here and drag this on. Now, there's one small issue, is that FPGA cannot deal with floating point. So you'll have to change these. And you can either just make them integers, or you can use fixed point. Fixed point is a little bit more confusing. Fixed point says how many points you force a certain number of points behind the decimal point, and it means that you'll only have, say, two values behind the decimal point. These fixings can all be adjusted under properties, and one of the properties of a fixed point will be how many points behind the decimal point. In general, I'd recommend against using fixed point. I'd recommend sticking with integers at the FPGA level and then doing all your analysis at the real-time machine level. As you can see here, I can pick that it's fixed point. We have a 64-bit long word with the integer part being 32 bits and the other 32 bits being decimal. Okay, so you can again hit run. Now if I hit run, it actually looks for the compiler. It again wants you to save, and then it'll look for the compiler. It'll compile it. It'll take about 10 minutes, probably 5-10 minutes, and move it down. Then once you have it compiled, you can hit run as many times as you want, and it will actually again update your front panel just as before. So you can run on the FPGA and make sure that that is working too. So the only thing left, though, is you probably don't want to be multiplying two numbers. You might want to be turning on and off the digital line. So let's say we want to go to FPGA and the node. This is the only thing you're going to need, FPGA node. And you can say under connector 0, we want digital line 0, say. And we're going to want to flip that on and off. So we're going to actually make this right, because I'm going to write to it, and I'm going to write it to be a low, false, and then some while later I want it to go on. So I'll make that true with some time delay in between. So I will say wait in there. And you'll notice you can wait for ticks. Remember, there's 40 million ticks a second, or I can wait for microseconds, or I can wait for milliseconds. And you just wire in how many microseconds you want to wait. So we'll wait how many microseconds. And it's going to not be able to try and run all these at the same time, so I'm going to throw in a sequence structure. We'll put these all in a sequence structure. And if you now try running this, it'll flip the DIO line low to high. If I stick in the loop, I can do it a certain amount of times. So I want to keep it high for a okay, and then maybe I want to clean up my diagram as well. Okay, so now maybe the number of times I run the loop, though, I want to be something that I will enter. So here I've got something that will flip digital line 0 as many times as I have on the front panel. So let's save this. Okay, so go here and call this the FPGA code. And now if I go back to my real-time program, which remember is right here, I can say what I really would like to do on this guy is not multiply two numbers, but instead call that FPGA code. So if I go under FPGA interface, there are a couple of things I want from here. One, I want to open a connection to that FPGA target. I want to write how many times I want to run the loop, and then I'm going to close the connection. So the first thing I have to do is then say, here, configure the reference. I'm going to say it's going to be VI, and it's going to come up with a list of the ones in the project. I guess there's untitled FPGA code 3, so that's what we'll go with. Okay, so now it knows in the VI if I had a nice icon, the nice icon will appear there. I can connect this up, and the error up, and now this has a drop-down list of all the things that you have on your front panel. So it can be, you can write or read to anything on your front panel. So if I actually reading an A to D value, I can put that as an indicator, and that would come up in this list as well. And I can write here a control of how many iterations I'm going to run. So now this, if I said I want to run 100 times and hit run, it would run that, pulse that line 100 times. And you can see if you want to add multiple lines, you can have multiple for loops in your FPGA code. So the key point here now is on the FPGA code. If I want to do something else at the same time, say for instance maybe read an analog input, that could be a completely separate loop. So I could throw up another while loop that maybe runs forever, and maybe we continually read analog 0, analog in 0. And so we can continually shove that out to end. So this will continually read the analog 0 and stick it to this front panel control, and will, for as many times as you said iterations, will run that many pulses. If I go back to my real-time code, you can see now I can reconnect. Oh, I have to save, sorry. Save that. And then you can see now that I saved it, analog 0 also comes up here. So now I can do a second read, right? And in this case, I'm going to read the analog 0 and show it to my graph. And maybe I'll stick that could stick it in a loop and it would continually read the analog 0. Again, you hit save, and you hit run, and away it runs. So that's a quick overview of how to get started in getting a program running on the RIO. Hopefully this helps.